Good morning to the esteemed speakers and veteran authors and academicians. Welcome to the fourth International Conference on Computation, Automation, and Knowledge Management. Let me introduce you with our team, Yashika Garg, Vansh Garg, and me, Shivam Gupta. We are the coordinators for this research track 1. Dear authors, before we begin, allow me to share the objectives of the conference. The objectives of the conference is to address the most essential issues of engineering, technology, computation, automation, and knowledge management. It also serves to foster communication among researchers and practitioners working in a wide variety of scientific areas with a common interest in improvement of engineering, technology, and knowledge management related tools and techniques. It aims to bring in the academicians and practitioners to jointly discuss and deliberate through their plenary talks and paper presentations on the theme Engineering, Information Technology, Operations and Knowledge Management. The conference will provide a common platform to foster research relations between the universities and the industry. The vision of the conference is to bring technology experts in one venue, not only to present breakthrough research in the area of computation and automation application, but also to promote practicality and applications in interdisciplinary exchange of ideas.
Now I would like to introduce you all to our session chairs. So first we have Dr. Ranjit Kaur. Dr. Ranjit Kaur is a dynamic academician specialization in the domains of social marketing, behavior change, and the application of marketing principles for positive and social transformation. She completed her doctorate in philosophy in marketing at Dr. B.R. Ambedkar National Institute of Technology, Jalandhar. Delving deep into the intricate mechanics of behavioral change, Dr. Kaur has contributed extensively to the field through her publication in esteemed journals, notably her articles including those in Journal of Social Marketing and Social Responsibility Journal. Her explored critical factors influencing anti-littering behavior, leveraging innovation frameworks and models. Dr. Kaur's academic emissions extends beyond publication. She has played a vital role in organizing prestigious international conference and presenting her research in eminent platform, including the world's social marketing conferences. Can we have a few words from you, ma'am?
Yeah, thank you. Thank you so much for such a lovely introduction, and looking forward, to very interesting papers and more interesting interactions. All the best, everyone.
Thank you so much, ma'am. Next, we have Dr. Vinita Sharma. Dr. Vinita Sharma is an academician over 23 years of rich experience of teaching and training. Her area of interest is IT and analytics with special expertise in area of management information systems, e-business, machine learning, data analytics, Python, R, business intelligence, and data visualization through Tableau and Power BI. Data modeling and data analysis through advanced MS Excel. Professor Sharma has various publications in Scopus and UGC Care. Listed journals to her credit and presented various papers in prestigious national and international conferences. We welcome you, ma'am. Can we have a few words from you?
Thanks, Vansh, for this introduction. Thank you. Please proceed further.
Next up, we have Dr. Asha Madhavan. She's an academician she's an academician with a wide range of basically
wide range of research papers and in various international and national conferences. She has written various chapters and books. We welcome you, Dr. Asha. Would you like to say something? Few words, ma'am? You are on mute, ma'am.
Hi, good morning. I'm Dr. Asha supporting from Amit University Dubai campus. And I work here as a program leader for the nanotechnology. So warm welcome to all of you. Thank you so much.
Thanks, ma'am. Yeah, let's proceed further.
So now I would like you to, I have some brief guidelines. for the authors. Dear author, we request your presentation. However, we strictly follow the timeline of 10 minutes, out of which 7 minutes are for presenting and 3 minutes are for questioning. That mainly include the objective of the study, research methodology, data analysis, and conclusion. At the end of the session, in the valedictory, the best author will be declared.
Now, I would like to call our presenter with paper ID 1, I repeat, paper ID 1 entitled Conformer CTC with Language Models for Improving the Performance of Automatic Speech Recognition. Can we have the presenter here?
Yashika, can you name the presenter also?
It's Kartika Renuka D. Do we have the presenter for paper ID 1 here?
I don't think the presenter is there. We can proceed further.
Okay, I would like to call our next presenter with paper ID 3. I repeat, paper ID 3. A study on analyzing the importance of factors impacting shipping in maritime industry in the content of the Indian economy and APH approach.
Good morning, everyone. I'll be presenting on behalf of Dr. Supriya Lamba Sehdev. My name is Shreyoshi Banerjee, and I'm a student. We are currently associated with the ISBR Business School, Bangalore. I'm a second-year operations management student, and Supriya ma'am has helped me write this paper on the importance of factors of shipping in the maritime industry of India. So, can I share my screen? I have a PPT prepared.
Yeah, you can share your screen.
Thank you, Yashika. Is it visible?
Yeah, is it visible?
Yeah. So, the title of my paper is a study on analyzing the importance of factors impacting shipping in maritime industry in the context of the Indian economy. We've used the AHP approach for the analysis. So I'll just give you an overview of the topic. So our research paper mainly focuses on the maritime business of India, and we wanted to study the current status, the trends, and the challenges that the Indian ports and the Indian maritime business is facing currently. So it covers, we have listed out the factors of that is basically affecting the maritime business of India, and how digitization and automation can be a sustainable approach for the globalization of the shipping industry of India. So when we talk about shipping, we always relate to ports, and India, as we know, is the largest logistics of India is ship logistics, or the main movement of Indian cargo is through ships. So Indian ports, India is not only just shipping. India's shipping business just is not confined to ports and shipping, but also shipbuilding and ship repair, which is a huge industry and contributes a great amount of GDP of the country. So the Ministry of Shipping is currently the Ministry of Shipping is currently has launched the Sagar Mara program and the Gati Shakti program, which is a national importance NLP program, and where roads and railways and shipping are all coming together for a better logistics to reduce lead times of of the shipping of cargo. So I have a literature review. I'm sorry. The literature review, I have studied all the papers. We have currently studied all the papers from 2019 to 2023. And we have the paper of, just a minute, please. Yeah, we have the paper of paper by Bishal Sarkar and Ravi Shankar, which is titled Understanding the Barriers of Port Logistics for Effective Operations in the Industry 4.0 Era, Data-Driven Decision Making, which talks about the port managers or the port logistics people in identifying the inadequacies that they face during cargo handling. So this paper talks about what is commonly known as the ICT, or the Information and Communication Technology. Next, we have the factors listed. So we have identified 6 factors. The economic factors, how our global economic conditions have affected the shipping industry in India. It talks about all the currencies, trade policies, exchange rates, and various other things. The political factors, one of the main factors which results in political tensions or discrepancies in state governments, and not one the union government's plan and the state government's plan. The environmental factors come next. So the shipping industry's IMO limits the use of emission of sulfur from ships that actually affects sea life and the marine life. Yashika, please do me a favor. Please let me know 1 minute before the time is over.
Yeah, sure, ma'am. I will be.
Thank you. Next, we have the technological factors. So technologies such as autonomous ships, GPS tracking systems, and everything that might improve the efficiency and the operating costs in the shipping industry. New technologies are also coming up, which is there is a gap in the research, because as we all know, technology is ever changing, so it cannot be encompassed thoroughly in one paper. There are labor factors, because it's a very labor intensive industry. Though automation has come up, yet maritime and shipping industry relies heavily on skilled labor and captains, engineers, and there are labor laws, workforce demographics, so cost of labor. There are many factors that affects the labor situation in the shipping industry. Next, we have the safety and security factors. So as we all know, there's ship terrorism, there is safety concerns in transporting the cargo from one place to another. So, and since India also has a pipeline system which is underwater, there are many pipeline systems underwater. So that too is a factor, safety factor, that has been concluded with. So this is the flow chart of the factors: government regulations, infrastructure.
You have 1 minute left.
Okay. Technological innovation, safety, security, computation, environmental. And we've used the research methodology. We've created a questionnaire in English, including both open-ended and close-ended questions. And we've put a random scale, random index, and the questionnaire was sent across through people connected on LinkedIn. This is the AHP model, the outline of the model, and this is the criteria for rating. Next, as we all can see, political factors remain number 1 according to our research. Next, followed by the technological factors, then the environmental factors, followed by labor, safety and security, and the economic factors. There are subdivisions of all the factors, government policies and everything. So as we all know, political, technological, as I just said, political, technological, environmental, labor, safety and security, and economic factors are the main. And these are the sub factors that play a great role in the shipping industry of India. The conclusion, thank you. The conclusion is the proposed model can be used in future academic and entrepreneurial studies, and also serves as a towards sustainable development goals, goal number 9, in which we talk about industry, innovation, and infrastructure, especially when Indian economy is impacted by COVID-19. So there, as I said, there are many loopholes, as in the technology cannot be encompassed in a single paper. Further, there can be discrepancies in the AHP methodology, where interrelationships can be made between different levels and within the same level, while we group the factors and the sub-factors. Thank you so much.
Thank you so much, ma'am. That was an amazing presentation. I would
Thank you.
invite the session chair to ask the question, if any, and conclude it with marking the judgment sheet.
Okay. Hi, Sreyashi. Shall I
Hi,
start
hi.
first,
You
Dr.
surely,
Vinita?
ma'am.
Yeah. So amazing presentation, good
Thank you, ma'am.
presentation,
Thank you so
and
much.
I would request, I think, all the presenters to focus less on intro and the initial parts of the paper, and maybe focus more on your findings and implications, because I think that's what matters, right? Like you said, the political factors came out to be the most important factor.
Yes, ma'am.
Yeah, so I think, how do you envision the practical implication of this specific finding, within the
Yes, ma'am.
Indian maritime industry?
Right,
Are there
ma'am.
any, so because you said, it might help in policy making, are there any specific implications for the same?
Ma'am, for specific implications, right now we haven't found out any, but as we all know, the Indian government has launched the Gati Shakti plan, under which there's the Sagarmala plan. So that is an unified, that talks about the unification of the entire Indian maritime system in under one umbrella. So if that is implemented properly, I think that the discrepancies in the state government plays in the shipping industry, it's not complete. It's a mix of both the policies of the union government and the state government. So both of them coming together and solving the discrepancies could actually solve the confusion in the policy makers in the shipping, related to the shipping industries. Like, for my example, if I may say, a ship follows a specific route, and the central government has provided a subsidy, but a state government imposes a heavy tax on the same good. So that is a confusion, whether the exporter or the shipping people will export that good through that state or not.
Okay. One more question from me, I
Yes.
think, and I will not waste a lot of time, right? So one more question is, so you rated all these factors, right? Political, and then I think technological, and so on. I think environmental after that. Yeah. So was these in coherence with the existing studies, or it was, was there any unexpected findings from your study that
No, ma'am.
contradicted the
No, ma'am.
conventional literature? So all
No,
this
ma'am.
was already, it is in line with the current literature.
Current literature, and we have done the literature study of the very current age of from 2019 to 2023. Till 2023 January, as if you go through the paper, there are many studies listed in the paper. I've just taken out the most specific study,
Okay,
which
so
talks about.
Okay, so you're saying that in earlier studies also, the political
Yes.
factors came out to
Yes,
be the
ma'am.
most important part.
Yes, ma'am. Because it is always the first, there was the excise and the customs department headed by the union ministry. Now also they play a part, and now with the Gati Shakti Sagarmala plan, the political factors have always been very relevant to the shipping industry.
Okay, interesting. Thank you so much.
Thank
That's
you
it
so
from
much,
me.
ma'am. Thank you.
Yeah.
Thank you so much, ma'am.
Thank
Now I would like to call our new presenter, next presenter, paper ID 6. I repeat, paper ID 6, entitled From Knowledge Management to a Learning Organization, Strategic Use of AI Tools. Do we have the presenter here for paper ID 6? I repeat, paper ID 6. The name, Kimberly Nault. I repeat, paper ID 6. So I think we don't have paper ID 6. We will be moving ahead. Now, I would like to call upon next presenter with paper ID 8. I repeat, paper ID 8, entitled Brain Tumor Prediction and Cataloging Based on the Medical Resonance Imaging of the Brain Using CNN Reset. Name Ganeshwari. Paper ID 8, Ganeshwari, are you here? Next presenter, paper ID 16. I repeat, paper ID 16, entitled Potato Disease Detection Using Deep Learning, author Anish Gupta. Do we have paper ID 16, Anish Gupta here? Okay. Next paper ID 17, entitled A Comparison of Face Landmark Detection Techniques. Paper ID 17.
Good morning. Good morning, Ashika. I'm here. Can I start my PPT?
Yeah, you can. You can share the screen and start it.
Thank you. Okay. I think my screen is visible. Good morning, everybody.
Yeah, your screen
Thank you, Yashika. Good morning. I am Rajnandini Bhowmik. Currently, I am doing my 4th year from Chandigarh University, and my specialization is in computer science engineering, artificial intelligence, and machine learning. I have done this research paper along with my teammate Ritika Chandil. She is not present over here under the supervision of Dr. U. Hariharan. I think my research paper is very interesting. The topic of the research paper is a comparison on facial landmark detection techniques. Since we know that face is one of the most common feature in a human body, and I think face can be influenced by cosmetics or lighting conditions or emotions, but then it is one of the most favorable feature that makes a human body identical. So my research, let me come to the research objective. The aim of my research paper is to compare two face landmark detection algorithm, that is the 68-point face landmark detection algorithm and media-pipe face landmark. So in the whole research, I have used a standard data set, that is Yale face database. The images of each of the people has 11 images, which are in GIF format, and that sums up to total of 165 grayscale images. And in this research paper, we have categorized a human image in various expressions, like whether the image is sad or joyful or he is drowsy. Now the methodology, we have worked on Jupyter Notebook. At first, we have downloaded or installed various libraries. For example, it's written Python, NumPy, OpenCV, Dilib, and then we have installed imported the dataset, and we have imported various libraries. And based on the images that are present in the dataset, we have compared the images based on the accuracy, time taken, precision, speed, etc. by using both the algorithms. And our main task was to find out which of the algorithm works better. And these are the results. We found that the face landmark detection algorithm can detect almost a total of 68 expressions in a human image, whereas a media-pipe face landmarker can detect 468 landmarks. In this case, I think MediaPipe works better. But then the problem with MediaPipe was that it can work only with 3-channel image. So it is ineffective with the image that has only 1 channel. But then we found that Dilip works better since the speed of Dilip is much faster. But in MediaPipe, we found that it can detect more expressions of a human face than the Dilip face landmarker detection algorithm. And the research gap is that, for example, and one more thing I can, and the most important thing we can see over here in this image, that in Dilip, the sad expression, a human image with a sad expression, the Dilip detection algorithm will mark the landmark below the lower lips. And as we can see over here, the media pipe works only with 3-channel image. So it is ineffective for only 1-channel image. And the research gap is about, we have, in this research paper, we have not worked with the distances of the landmarks, between the landmarks. For example, what is the distance between the eyes, or what is the distance between the ears? We have not worked with that. We will surely try to do that in the future. And one more is that we will try to give, in this research paper or in this thing, we have already we have used images as input, but in next time we will try to use a video as an input. Thank you.
Thank you so much, ma'am. This was an amazing presentation. I would request the session chair to ask the questions, if any.
Hi, Rajnandini. Good presentation, very interesting study indeed. Like you said, one question I have is, you mentioned a few places where probably media pipe was better, and a few things probably, in terms of speed where relib was better. So based on your findings, are there any specific domains or applications where DLIB's 68 landmark detection technique or media pipes approach, it does stand out? So, basically I want to know what are some potential use cases for each technique, and how do you make so how would these strengths in probably various areas, as you found out in your study, would be useful there, right?
Yes, ma'am. There are several real-time applications as well. For since we know that both are both are face detection algorithms. So some of the things are common in both too. So they both can detect some of the common facial expressions. For example, sadness, or a person with a tilted face, or a person who is full of joy. So the real-time applications can include, for example, if a person is driving a car, and maybe there is some accident that occurs, so we can judge using this face landmark technique that whether like the eye directions of the driver, or whether he was attentive or not, whether he was looking forward or whether his head was tilted. We can study the human expressions using this algorithms.
Okay, thank you so much, Rajnandini. That's it from me.
Thank you.
Any other questions? Do we have any questions from Asha ma'am and Vinita ma'am?
I think let's go ahead. Thank you.
Thank you.
Thank you so much.
Now, I would like to call our next presenter with paper ID 282. I repeat, paper ID 282, entitled Resolving Remote Healthcare Prospecting and EIoT and Integrated Approach for Real-Time Health Monitoring by Danish et al. I repeat, paper ID 282 by Danish. Do we have the author here? Okay. Now, next paper ID 286, entitled Enhancing Used Automobile Valuations, a Data Cleansing and Linear Regression Approach for Predicting Prices in Competitive Market. Author Danish et al. I repeat, 286. Author Danish.
I think, Yashika, let's go ahead.
Okay. Next paper ID 23. I repeat, paper ID 23.
Just a minute. Mr. Rajneesh, you tried to say something?
And I requested to change the presenter
I'm
name.
not able to listen to you. Can you please repeat?
Hello, am I audible, ma'am?
Yeah, now you are audible.
Right. So paper ID 286, I would like to present, ma'am, because I am a co-author. Dr. Danish is little occupied, but paper ID 286, I would like to present.
Yeah, most welcome, sir.
Right.
Yeah,
Thank you so much.
Thank you. So you can share your screen and you can start with your presentation.
I hope it is visible.
Yes, sir, your screen is visible.
All right. Very good morning to everybody and good afternoon to respective session chairs. I'm Dr. Rajesh Clare. I'm the co-author with this paper, which titles Enhancing Used Automobile Valuation, a Data Cleaning and Linear Regression Approach for Predicting Prices in a Competitive Market. See, the idea of this research came from very intuitively when I was looking for a used automobile in India. And I was going through the stratified ads, the online ads which gives you the various details about the automobiles, such as their models, make, their kilometers driven, and so on. And it becomes very difficult to choose that which vehicle one should buy. So that gave me a motivation to develop a model or a predictive kind of a model where the dealers as well as the consumers who are there in this very competitive market can predict the prices by looking at the various variables, various factors which may influence the prices of these used automobiles. So these online classified ads on times give you data which is very complex. So there are lots of problems, like for example, the model names are different, the makes are different, the year sometimes are missing, sometimes the kilometer driven are missing, and so on. So what I thought is that first of all, to predict the prices, first of all, a data cleaning is required. So main objective of this particular study is to see that how we can clean the data, first of all, by using certain algorithms and certain techniques. And after that cleaning of the data, how a simple regression model can be used to predict the prices of the used vehicles by taking some of the explanatory variables. So that is the motivation behind the study. Not much of the literature on this particular competitive market is available because this used automobile markets are very, I would say it's a gray area. It's not a very, kind of a formal kind of a setup. We could not find many of the researchers which have really dealt with looking into such data cleaning techniques for this particular competitive market. So in methodology, first of all, we saw that in the data there were inconsistent naming. There were errors in the company's name. There were errors in the values of the year, and so on. So this motivated us to first of all look at data cleaning. So in data cleaning, we identified and removal of the spams. So wherever there was the spams, so we developed an algorithm to identify those spams and remove those spams. Then standardization of the names. So for example, it is Maruti, let us say Baleno. So Maruti Baleno, somebody would put as Maruti Baleno XS, somebody would put at something else. So that standardization was also required. And we had brands, all of the brands, in fact, which are bought and sold in the second-hand market. Right, so it included Tata, it included Hyundai, it included Maruti, it included Mahindra, and so on. After this data cleaning, we went for the data transformation. So by normalizing the data, we transform the data which can be used for model building. And then we choose a simple regression model, not a very complicated technique, where we took the prices of the vehicles as the dependent variable, and explanatory variables were model types, kilometer driven, year of manufacturing, and we also included the dummy variables for the make of the model to see the perceived value of the consumers, that which brand has more perceived value. So there was a dummy variable which was taken. And we could predict the price with a very high R square, which is 0.99, and the root mean square error, which is also quite significant. And if you look at this figure, let me put it on the full screen, maybe the figure will be much more clear. If you look at these green dots are the predicted prices, the actual prices, and this yellow line is the predicted prices from our model. And in this prediction, two variables were most significant. The most significant variable, kilometer driven, with a high coefficient and very low t statistics value. And the second was the perceived value. And within the perceived value, we found that Maruti has the highest perceived value among all other brands. And we know that in India, in the Indian market, Maruti is one vehicle which is always first preference of the choice. But with this model, it was quite apparent that Maruti, although now the other brands are also building up, but Maruti still have the significant share even in the second-hand markets. So this kind of model can be used by the dealers, by the buyers, by the online market platforms, and people can decide that what is the apparent price for a particular vehicle, given the factors like kilometer driven and year of manufacturing and so on. Thank you.
Thank you so much, sir. That was an amazing presentation. I would request the session chair to ask the question, if any, and conclude with marking the judgment sheet.
Yeah, Dr. Rajneesh, an interesting study indeed, and I loved the way you started the presentation. So I generally, a personal preference for such kind of style of presentation where you start with building the rationale of the study by, giving a story that, maybe this triggered me to actually delve deeper in this certain area. So I think that's the same way I presented my own doctoral thesis. I started with my life story and why did it actually choose this topic. Yeah, but the dummy variable that you introduced, perceived quality, a very interesting thing, and I think that's one of the most important variables in India. So, for example, whenever we look at any used car, so my husband will always say that in Toyota cars they have more perceived value. So I'm very intrigued by this certain variable, and I want to know how did you quantify? How did you give values to various companies? Let's say, for example, if you're saying that Maruti ki sabse zyada perceived value hai, was it subjective? If subjective,
not subjective, ma'am, not subjective. So when we take the dummy variable, so for example, I have 8 brands in my data set.
Right.
So in 8 brands, all the observation which belongs to Maruti would take value 1, and it will take value 0 for all other brands.
Okay, right.
And that will be included as one of the dependent variable.
Okay. And one more thing I want to know that why linear regression only? Did you look at some other machine learning algorithms or some other models that you probably
we use the algorithms to clean the data, right? To clean the data, and then applied the regression model. Otherwise, it was impossible to apply the regression model because the data was so rough and it was so complex that even the regression model will not give any results.
Okay, and did you are you planning to apply, because it's actually an interesting model? So have you considered maybe in the future, in some future research, you'll incorporate some additional techniques to enhance the accuracy of the predictions,
indeed,
beyond the scope of linear regression? Are you planning to?
What I would prefer to do is a survey with the used car owners who want to buy a used car and who want to sell the used car. So I would like to see the perspective of the people on a binary yes or no kind of a thing, and then may apply some kind of logistic regressions or some kind of probit models which will give us more likelihood that whether given these variables and factors, some consumers what is the probability of these consumers of buying a particular used car.
Okay, perfect. Thank you so much. Interesting study indeed. Yeah.
Thank you, ma'am.
Any other questions? Okay, so let's proceed further. Now I would like to call our next presenter with paper ID 23. I repeat, paper ID 23, entitled Current Harmonic Reduction Based on Fractional Order Filter by a Grid Connected PV System by Musad Zakira Abdul Rahim. By Musad Zakira Abdul Rahim. I repeat, paper ID 23.
Mr. Rajneesh, is there any other paper also which you want to present?
Yes, ma'am. There's one more paper ID 283. In fact, it is the next one in the schedule.
Okay.
Right.
Then I think you can also go ahead with that paper.
Sure, ma'am. Let me share the screen. I hope it is visible, ma'am. Yes.
Yes, sir. Screen is visible.
Okay. All right. Now, this study also has a little background. Actually, I'm here in Uzbekistan, Tashkent, from last 1.5 years or so with MIT University. I joined in September 2022. And I've been traveling, length and breadth of this country. And I found very interesting facts about the countries. Basically, I'm an economist. So, but yes, I also have, little inclination towards the machine learning techniques and application of Pythons in model building, which I recently started learning also. So as an economist, I saw that this country has very, very good rich resources, natural resources, and particularly cotton. Cotton is one of the things which has grown very strongly over here, and the exports of cottons from Uzbekistan to rest of the world are very high. But the domestic consumption of cotton is very low. I mean, their government policies are as such that they do not allow to process the cotton. In fact, the unprocessed cotton is being exported to the rest of the countries. So one of the prominent regions in Uzbekistan, which is one of the leading production of cotton happens, is Zizak, which is approximately 3 hours away from Tashkent. So when I was traveling, I saw those cotton fields, and so then I inquired with some of the agriculture people that what do you do with this cotton? Because when we go to the market here and buy clothes, you will hardly find manufactured clothes of cotton which are made in Uzbekistan. You will find it from made in Turkey, you will find it from made in China, and in many other countries, but not in-house manufacturing of cotton is happening. So then I looked into the government policies, that what are the policies, and then came to know that these policies are very stringent in terms of use of cotton domestically. Then I try to see that how the government policies are affecting the growth rates of agriculture production, particularly which includes primarily cotton, one of the prominent commodity. So that was the motivation behind this study, and we tried to predict the growth in the agriculture sector year on year for the next 5 years by using some of the ML techniques such as the support vector machines and neural networks, which have already been applied into some other contexts, not only just in agriculture, but in various contexts, these methods have been applied. And one of the model for forecasting, for predicting, which has been very successful in the other studies also, is the ARIMA models, which is autoregressive integrated moving average models, which is a basically time series kind of econometrics. So there were some studies like Smith and Jones, they used the traditional forecasting methods. Lee et al. Used ML in agriculture with random forest. Then there were other regression models, and ARIMA models are also being used. So we took the data from the government statistics of Uzbekistan from the year 2000 to 2023. I understand these observations are little lesser for a predictive analysis, but we tried to fit up the model which can give us strong and robust estimates. Because for time series, generally, we should have 100+ observations for strong predictions. But given the data set, we could do as much justice as we could. So looking at the time series graph and the augmented Dickey-Fuller test, we see that the series is stationary, which means that it does not show any seasonalities or any trends or any patterns. So this is quite stationary series, which means which can be used for the further analysis. The autocorrelation graphs, the AC and PAC functions, this although suggests that there is some autoregressive movement, right? If you look at these blue dots here, So these blue dots in the AC graph are following a pattern, right? Are following a pattern. But after that, we cannot see a pattern. But in between, we can see there is a pattern, which means that the current value has been influenced by the previous value. Whereas the PAC graph does not show such indication that the errors are following any pattern. So errors are quite random. They are not following any pattern, which is a good news for us, which means that the moving average component is not present, but auto-regressive component is present. And thereby we fit up the model, the ARIMA 100, okay, which was quite significant with the p-value of less than 0.005. And this graph, if you see, let me again put it on full screen, it will be better. The blue one is the actual growth rate, okay, of agriculture production. And the red one is the predicted growth rate from our model that we fit, the ARIMA 100. It follows the pattern of actual growth rates, not very closely, but still. We tried other models also, 111, 102, but this was the best of the prediction which we could see. And based on this, we predicted the growth rate for next 5 years, where the growth rate currently, which is about 105. So these are the indexed values, not in percentages. So the growth index, we are predicting that in coming time by 2028 should reach by 105. Now, given this prediction, what can be done is the appropriate policy guidelines can be recommended to the government of Uzbekistan, the FAO also, where some of the policies may be relooked, that how to boost up this growth rate in the agriculture domain, particularly in the ZAC region and particularly for cotton production. Thank you.
Thank you so much, sir. That was an amazing presentation. I would request the session chair to ask the question, if any, and conclude it with marking the judgment sheet.
Okay, Dr. Rajneesh, again, interesting study. One question I have is, and then I want to discuss something with you on the same topic. The first thing is, you told a lot of models that that have been used for these kind of studies. So, why ARIMA? Why did you choose a certain model as a primary predictive model for forecasting agricultural growth? Were there some specific characteristics of your data that suited? So, like you said, the data was less, or we did not find a lot of things in the data. So were there any specific characteristics of the data that suited ARIMA over other models?
Ma'am, okay, let me touch upon it. The AR, MA, and ARIMA, all these models are used for the univariate forecasting, where we are looking at one series only, or we are not examining the relationship between two variables. Whereas when we talk about the multivariate time series models, so those models are used to look at the interrelation between two series, which may be integrated to each other. So those models like VAR models and ECM models and so on. And if the data is highly volatile, like for example, stock market prices, then ARIMA models are not suitable. But we see that this data was not very volatile, and that's why we choose the model.
Okay, wonderful. One more thing, slightly off topic, but again on the same areas. There's a company I just wrote a case study with, a company named Indorama. I'm not sure if you know that. That company is into cotton farming only, especially in Uzbekistan. And they're trying to, they even got their funds from IMF, and they're trying to implement Better Cotton Initiative, BCI, right? For the welfare of the workers, probably agricultural workers in Uzbekistan. So, do you think probably the implementation of BCI would somehow link up, because they're using more sustainable and modern agricultural practices. So will it probably impact the agricultural growth here also?
Yes, ma'am. Ma'am, certainly, because see, right now the concern of the Uzbekistan economy is to shift towards more market-based economy. So until a long period, this economy was more often a command-based system. Okay, the policies were also very stringent. but now they are opening up FDI in various sectors, right? And there are certain Turkish companies which have been allowed to set up their manufacturing units in Uzbekistan.
Right.
So certainly, I think that this growth in agriculture sector, particularly in cotton, would be robustly increasing in coming time with the initiatives that the government is taking. In fact, with this study, we also recommend that the domestic consumption of cotton should be increased rather than only focusing on the exports of raw cotton.
Yeah, wonderful. Thank you. Thank you so much. That's it for me.
Thank you, ma'am.
Thank you.
Do we have any other questions? Okay. Now, Dr. Rajneesh, sir, I want to ask you one more thing. You have another paper also. Do you want to present it now?
Dr. Rajneesh, are you there? So let's do with another paper, another author.
Now, I would like to call paper ID 30, I repeat, paper ID 30, Twitter sentiment analysis and emotion detection using NLTK and text law by Nehal. I repeat, by Nehal.
Hello, very good morning to all the honorable panel members present here. I'm Nehal from Kalinga Institute of Industrial Technology from School of Computer Science and Engineering, and I'll be presenting my study on Twitter sentiment analysis and emotion detection using NLTK and TextBlock on behalf of my professor, Dr. Sushita Mishra. I'll just share my screen. Okay, so in this presentation, I would be covering these topics mainly. And the aim of this research was to use sentiment analysis using Tweepy API on selective tweets available on Twitter to classify the tweets as either positive, negative, or neutral. For this study, we have utilized a TextBlob library in Python that allows us to process textual data easily and helps us to segregate customer sentiment on a scale of -1 to 1. Where -1 would represent a strongly negative sentiment and +1 would represent a strongly positive reaction. Next, sentiment analysis, classification. So there are various approaches to handle the classification of sentiments, and based on our research, okay. Yeah, based on the research and the literature review, first is the machine learning based model. So machine learning based analysis automatically classifies the text attributes and involves training an algorithm to identify relationships and patterns within labeled text data. Such data comes from text documents that typically were manually pre-labeled with positive, neutral, or negative sentiment. Then comes lexicon-based. So this methodology counts the number of positive, neutral, and negative words in a body of text and assigns a sentiment score based on the intensity and frequency of such words. For example, if a news article covering a product launch by a company includes more positive words than negative ones, the overall sentiment would be categorized as positive. Then comes the linguistic rule-based. So this popular approach provides a set of predefined handcrafted rules and patterns to identify sentiment-bearing words. And this method heavily depends on rules and word lexicons that might not apply for more nuanced analysis and text. Then comes the contextual embedding. So this neural network-based approach extracts complexity and nuance of words within given document based on interaction of unsupervised machine learning training models. And the last one is ensemble. So ensemble sentiment analysis can extend models between different domains, such as applying a model well trained on social listening to analyze financial reporting data and produce more accurate and reliable overall results. The one that we have used in this research is a lexicon-based approach. Next, I would like to explain why we specifically went for Twitter. Customers frequently use social media platforms to share their thoughts and experiences regarding goods and services. On a worldwide level, every second, around 6,000 tweets are sent, which counts to around 200 billion tweets in a year. People share their ideas and views publicly on Twitter, thus it serves as a good platform for analyzing public trends and behavior towards person, product, or news. Over the last decade, there has been a significant increase in the number of Twitter users, which illustrates the popularity of Twitter among masses worldwide. With the advancement of technology, we can fetch both static and real-time data from Twitter, which is useful for advanced researches. Twitter also has an abundance of user-generated data, and as we know, more the amount of data, more is the accuracy of the result. One benefit that Twitter holds over other social media platforms is that Twitter contains data mostly in textual format, whereas other social media platforms like YouTube, Instagram, or Facebook contains the data in image format or video format. So this makes Twitter more useful for analysis and study purposes. Then there are a lot of shopping apps currently that are launched newly or which do not have an advanced customer review section. So those apps can utilize Twitter to publish ads in order to get valuable customer feedback and review, which can help them for their growth. So these were the reasons to choose Twitter specifically for our research. Now I'd like to explain the motive for behind this research. We are currently living in an era dominated by digital technology where advancements are constantly pushing the boundaries. Data creation is occurring at an unprecedented rate with every passing second. From our social media interactions to the intricacies of stock market, banking transactions, ID operations, government processes, and various industries, data plays a pivotal role in driving these fields forward. Therefore, this study can be found to be useful not just in any particular field, but it can be applied in a lot of areas. So first, understanding customer opinion. Social media platforms are often used by customers to share their opinions and experiences about products or services. And it can also be used for monitoring brand reputation. So social media provides an open forum for customers to discuss and share their experiences with a brand. Sentiment analysis can help businesses to monitor and track customer sentiment.
Sorry to disturb, Nehal. Can we directly go to methodology part?
Okay, sure. I'd like to move forward. So yeah, this is the process flow diagram, or in short, the brief process that was followed. So we firstly use the Twitter API to collect our data, right? That was a API used for establishing a connection between Python and the Twitter app for data collection. Then after data collection, we went on the pre-processing steps. So the pre-processing steps included tokenization, data cleaning, removal of stop words, and this was the most challenging step in this study. Then comes applying sentiment analysis technique, for which we have utilized the TextBlob library. And the last one is, classifying the tweets as either positive, negative, or neutral. So here we've used Tweety API, right? So in this API, using this API, we can just enter any search keyword on the basis of which it will fetch the given number of tweets. Let's say we want 100 tweets or 200 tweets. So we can get the number of tweets, and then we can conduct a study on those tweets. So this Twitter API helped us to curate our data set. And the same goes for data collection. This was the methodology followed for our data collection. The data was saved in the CSV file, after which we use libraries like NumPy Pandas for reading, Matplotlib for...
Now, you have only 1 minute left.
Okay. I would like to move
Go
to
ahead
the
fast.
results.
That's why I asked to go to research methodology directly.
Sure, ma'am. So the final, I'd like to share the results, right? So this, as I mentioned, that this research or this study was not based on any particular field, and it can be extended to any domain, right? Like this graph depicts how we conducted a study for COVID-19, and we searched for 1,000 tweets. on the basis of which we found 400, more than 400 neutral tweets, 415 positive tweets, and a few negative tweets. Likewise, we can conduct the study on any given topic. Let's say a brand wants to launch a new product. So they would publish an ad on Twitter, and then on the basis of the tweets related to that brand, on the basis of the hashtags or any words, any tweets related containing that brand name, we can fetch those tweets and find whether the overall sentiment of public towards that product or towards that brand or company is positive, negative, or neutral. And one thing to note here is that this study can vary from time to time, right? Like, let's say at a certain time, people's opinion about a brand are all positive. But after a certain time, it can go neutral, it can go negative as well. So it depends on the data that we have selected for our study, and also on the current time. So this is since we are fetching data on a real-time basis, so our study depends totally on the data set that we are getting according to the given time. That's it. Thank you.
Thank you so much, ma'am. That was an amazing presentation. I would request the session chair to ask any question and mark the judgment sheet.
Nehal, what is the final outcome? What is the exact conclusion of the study?
Okay, so this paper, in this paper, we have conducted various methods that can be used for sentiment analysis. The literature review contains a lot of papers that shows what are the different methods and in which areas sentiment analysis has already been used to show people's sentiments, to
That's
conduct, to
fine, but
conclude.
what is the final outcome?
The paper is
Well,
about.
yeah.
Yes, so since we have used the text blob library, there are other uh, other alternate methods like Vader or Vader and machine learning technologies also that can be applied to this study. The motive of the paper, as I mentioned, was to find people's opinion about any given topic. So
That's
it can be
what I'm
used.
asking, Nehal.
Yes,
What
ma'am.
is the final outcome? We wanted to know the opinion of people.
Right. So as I shared, so topic has to be decided by the user, whoever is using this application. Let's say we want to know people's opinion about COVID-19. So based on our research, the tweets that we considered for our study, the most of the tweets were neutral.
Okay, thank you, Nehal.
Okay.
Anything from Dr. Ranjit's side?
Yeah, I think a similar thing, because I kept waiting that, probably there'll be some outcome that will tell me, what were the outcomes. But then you said they can be positive, they can be neutral. So slightly confused there. Yeah, so I think I would I would probably like to ask the implication part also, but then since the outcome is not clear, so obviously, you cannot reach an implication. Again, stressing on the same thing, do not waste time on the introduction and the literature review. Please try to connect, just focus on those aspects of the review which probably would connect with your findings, right? And let's delve more on that and less on the review part, right? Because that wastes your time, and we still can't make out that what was the finding of the study. Yeah, thank you, Nehal. Otherwise, yeah, good techniques were used, and I personally really like the sentiment analysis we did it, way back for Dabas in an organization. So
To
it's a good
conclude, I would
technique
just
otherwise.
like to, yeah, thank you, ma'am. To conclude, I'd just like to summarize the applications to which this can be applied. It can be applied for understanding customer opinions and monitoring brand reputations mostly, and also in identifying emerging trends. That's all. Thank you. Thank you so much for your time.
Thank you so much, Nehal. Thank you so much.
Thank you so much, ma'am. Now I would like to call our next presenter with paper ID 31. I repeat, paper ID 31, entitled Vehicular Proposition Velocity Forecasting Using OpenCV by Udyan Das.
Yes, Yashika. Am I audible?
Yeah, you are audible.
Okay.
You can share your screen.
Yes. Is the screen visible?
Yeah, your screen is visible.
So good morning, everyone. I am Udayan Das from Kalinga Institute of Industrial Technology, Bhubaneswar. I'm studying BTech in Computer Science and Engineering from fourth year, and my topic of the paper is predicting vehicular propagation velocity with OpenCV under the guidance of Dr. Sushruta Misra. So this paper investigates the prediction of vehicular propagation velocity using OpenCV. We will examine the strategies and tactics used in computer vision to gauge and forecast vehicle speed. The possible uses of this study in transportation technology will also be discussed. Okay. So let us understand what is vehicular propagation velocity. So this section will provide an in-depth analysis of vehicular propagation velocity and its importance in the field of traffic management. We will examine the various factors that influence vehicular speed, including road conditions, vehicle types, and environmental elements. So moving on to the next slide, we have the challenges in traditional methods. Traditional vehicular velocity forecasting methods face accuracy limitations, reliance on static models, and challenges with sparse and noisy data. These approaches often struggle with real-time updates, lack high spatial and temporal resolution. OpenCV emerges as a solution to address these challenges, providing a flexible platform for enhanced vehicular propagation velocity forecasting. So moving on to the next slide, let's have a look on the OpenCV. It is a versatile platform for computer vision. It offers functions for object detection, image recognition, and video tracking. As an open source platform, OpenCV promotes collaboration and continuous improvement. It is widely used in autonomous vehicles, and it is of continuous improvement. It is also used in augmented reality. With its extensive features and active community, OpenCV empowers users to achieve remarkable results. So moving on to next slide. Let's have the application in vehicular propagation velocity forecasting. OpenCV plays a pivotal role in improving vehicular propagation velocity forecasting. Its capability in real-time image processing and analysis contribute to more accurate predictions, enhancing overall transportation and efficiency. So the data collection and pre-processing in quality data in fundamental for effective velocity and forecasting. OpenCV facilitates streamlined data collection and pre-processing, ensuring the extraction of relevant features essential for accurate predictions. Furthermore, OpenCV's capabilities enables the handling of complex data scenarios and addressing challenges such as noisy and sparsity. So we have used a feature extraction for these OpenCV for the detection of the vehicular propagation. In this feature extraction phase, OpenCV excels at identifying and isolating crucial elements from preprocessed data. Leveraging advanced algorithms, it efficiently captures intricate patterns and dynamics, empowering the model and essential information for precise vehicular propagation velocity forecasting. This step is integral to enhance the accuracy and responsiveness of forecasting model in diverse traffic conditions. So for the results and evaluation, we highlight the successful outcomes. The velocity forecasting model demonstrates superior performance. Evaluation metrics and comparisons with traditional methods affirm its accuracy.
May I interrupt
establishing.
you?
Yes, ma'am.
Udyan, you explained so many things, but what are the features you really extracted, and what is the data? You're not showing
Yes,
that
ma'am.
part.
Yes, ma'am. This one. This is the block diagram for vehicle speed detection. How it is done by frame by frame. So first we read the input video frame by frame. Then we use the TensorFlow object detection API, and then we use the then it is divided into three parts: detected vehicle image,
But
which
you
is
must have collected some data after this.
yes, ma'am.
That's what I'm asking.
And this is the data that I've collected.
No, this is the model, Ludhian. I think from the very start, you just have all your slides are focusing more on justifying the specific, methodology. Ki why is OpenCV better? So it helps
Yeah.
in data in the slide of data collection also. You are in no in no slide are you telling us what is the kind of data that you collected. Neither are you telling us, how did you do it. So you're focusing more on the advantages of OpenCV, and it helps in accuracy. Its capabilities are this, but you're not telling us that what did you do, how did you collect the data, where is that data, what are the features that you
Okay,
used,
sorry.
right?
Yeah,
So
yeah,
it
yeah.
is focusing
Yeah,
on the overall methodology. So like, for example, I'll say that, structural path analysis
yeah.
using Amos is better, or using R is better, and I just keep delving in that only, and I'm not focused on my own study, right? So you wasted all the time on that only. I think that's what Vinita ma'am was also trying to say.
Okay, yeah.
Yeah, ma'am. Same.
Okay, actually, the data was collected in a Python notebook using the library OpenCV and CMake in Windows. And it was actually each vehicle when passes at a means after a threshold level, it collects each vehicle's data, means each vehicle speed. Like here, these are the vehicles coming. So this vehicle, if a vehicle is here 7 km per hour, it is passing, then it is collected into a Python file data.py file, which is in the backend.
Okay, and then quickly move on to your results, and I think conclude.
Yeah. So this is the result that if any vehicle passes over the threshold limit, if there is a threshold limit of 90 km per hour, if the vehicle passes over 90 km per hour, then this green box will turn into red, and it will be stored in another file that is known as speedlimit.py file. So, in future, moving on to the future developments and innovations, exploring future horizons, potential enhancement include integrating IoT and smart infrastructure,
Again,
summarizing key
one more question.
findings. Yes, ma'am.
In the previous screen which you showed, this is your own
Yes,
model
ma'am.
which you have created.
Yes, ma'am.
So you must have done some coding for this.
Yes, ma'am. I can show you that.
Yeah. So
Yes,
those
just
are
a
the parts
second.
which we are waiting for.
Yes, ma'am. Just a second.
Or if it is taking time, then you can go ahead.
No, ma'am. Just a second. I'm showing that. Ma'am, this is the coding that I've done. So this is the main file. Ma'am, is the screen visible?
Yes.
Yes, ma'am. This is the file that this is the Python main speeddate.py file that I've used the OpenCV library and dlib library with these other libraries also. So here's the code, ma'am. This function illustrates the multiple objects that I've shown here.
My
These are
point
the
is, you
multiple
must have
objects.
shown the screenshots of this coding also, instead of just explaining the methods.
Okay, ma'am. I didn't know about what to show.
Okay.
So I have
We can
shown
just
this.
move to
This
the
is the
results,
results
as
that I've shown.
Dr. Ranjit is saying. You can just move to the result conclusion.
Okay, ma'am. Here the vehicles that are stored in just a second, ma'am.
You may switch to your presentation screens and tell
Yes,
us
ma'am.
the result and conclusion.
Okay, ma'am. In conclusion, this paper has provided the insights into the analysis of vehicular propagation using OpenCV. We have examined the potential in computer vision in predicting vehicular speed and discussed the challenges and future prospects of this technology. And this is the end of the presentation.
Okay, thank you, Dhyan.
Thank you, ma'am.
Now, our next presenter. If you have any questions, present paper 285, geo-based monitoring of microclimatic variables for precision agriculture in sugar culture cultivation by Dr. Rajneesh.
It will be presented by Dr. Danish. Just now we received a message. Dr. Danish is there? Paper ID 285 will be presented by Dr. Danish. If he is not there, you can go ahead, Yashika.
Okay, so next paper ID 58, I repeat 58, entitled Artificial Neural Networks Based Risk Management Analysis of Modern Commercial Banks Using Behavioral Finance Theory by William P. I repeat, by William P. Do we have paper ID 58 here? Okay, so next paper ID 59. I repeat, paper ID 59, entitled Enterprise Human Resources Management Model by Artificial Intelligence, Digital Technology by William P. Do we have the presenter here? So carry forward. Next paper ID 244. I repeat, 244, entitled A Key Factor in Traffic Management Vehicle Spread Prediction Using Machine Learning by Ayush Maurya. Do we have Ayush Maurya here to present the paper? Dr. Rajneesh, will you be presenting for this? For your paper ID 285, if Dinesh is not here.
Paper 49. Yashika, you may call author of or presenter.
Yes, ma'am, paper 49. Good morning, ma'am. Am I audible to you? Am I audible to you, ma'am?
Yeah.
Yes, I'm paper number 49, and my should I start the presentation or I should wait?
I can check. Paper number 49 is not in our list. I think you are on some other track.
I'm in track number 2.
It is track number 1.
Okay, sorry. Should I disconnect now?
It will be better if you join track.
Okay, I'll be leaving your meeting. I'm joining track 2.
Yeah. Yashika, you can again ask presenters who were not present in the morning, and then we can again check. Somebody is there.
Okay, so paper ID 1, I repeat, paper ID 1, titled Confound CTC with Language Models for Improving the Performance of Automatic Machine Speech Recognition by Kartika Venukati. By Kartika Venukati.
Yes, Dr. Rajneesh, are you there to present another paper?
No, ma'am. That paper actually is authored by Dr. Danish only. Actually, there was a swap. So the two I presented where Dr. Danish name was there, I presented that. This paper is I'm a co-author, but mainly it has to be presented by Dr. Danish only.
If Dr. Danish can join the session and present it.
Ma'am, he is in exam duty actually. We are having end semester exams going on. So unfortunately, we will not be able to present, ma'am. Sorry.
Okay. So there is no other author present here who is liking to present the paper.
Hello.
Yes, Mr. Lalit Tyagi.
Yeah, good morning, madam. Yeah,
Good morning.
paper ID 16. So I'm available to present the paper.
Okay. Please start your paper.
Okay, thank you, ma'am. Yeah, slide is visible, ma'am.
Yes, your screen is visible, so you can start with your presentation.
Okay, good morning to all of you. Myself, Dr. Lalit Tyagi, presenting on potato disease detection using deep learning. Paper ID is number 16. So as you know, potato is an essential yield and a core diet for the majority population worldwide. However, yield of potatoes are often impaired by various infections, pathogens, and disease, resulting in significant economic losses. As you know, premature identifications and precise diagnosis of these diseases are critical for timely and effective management. But traditional methods of disease detections can be time-consuming and require expert knowledge. Modern advancement in deep learning and computer vision techniques have solved the foundations of the plant disease diagnosis industry. So with the help of the deep learning algorithms can quickly and accurately diagnose the crop disease by learning complicated patterns and attributes from photos. A deep learning based potato element detection system that can automatically detect and categorize disease in potato crops is anticipated in the research studies or presented following research study. The suggested approach makes use of a CNN design that was trained with a big data set consisting of images of photo leaves. The data set comprises different types of the potato disease resembling blight, early and late, and leaves that are healthy. CNN model is prepared to learn the discriminative features of these diseases, which are then used to classify new images into their respective categories. Implementation of the suggested system is evaluated utilizing various undertaking parameters like exactness, accuracy, and remembrance. The system has the potential to make decisions and can be support instrument to farmers and agronomists, enabling timely as well as effectively disease management and empowering them. There are some related work, or you can say literature survey on this one here. As we have mentioned in the reference, so they were mentioning as 32, 21, etc. here. There are the different surveys here. Those are based on the deep learning as well as. So one has the introduced dual approach to automatically identify and classify agricultural in this research. Offered dataset contains 20,636 images divided into 15 categories, such as healthy leaves and tomato pipa potato disorders. CNN's training and testing accuracy rates were 98.29 and 98.029 respectively, demonstrating exceptional precision. In paper number 21, and potato virus (PVY) had severe economic consequences on potato farmers and seed suppliers. Current efforts to control the disease, including visual inspections and inadequate. So using near and short wave infrared wavelengths, machine learning classifiers, and remote sensing technologies can differentiate between potato virus Y infected and non-infecting plants with an accuracy as 89.8%. So there are so many surveys I have mentioned here. If you are interested, then I can cover. There are 5-6 slides. or just can leave this one?
No, sure. I think Yashika, he still has time.
There are
Yes,
the surveys
it's
they have
fine.
mentioned in the references. If you are interested, I can.
Yeah,
Just
please. Yeah, please quickly. You
2 minutes.
you can. Yeah, you can finish the slides. Yeah.
on methodology. Okay.
Yeah, please do that.
Okay. So this is the proposed methodology, data collections and pre-processing. So to ensure the robustness of our CNN, convolutional neural network model for the potato diseases, meticulous curations of a comprehensive data set was undertaken. And we have find out the data set in terms of the xi, yi from I-1 to n, as xi is the ith image and yi its corresponding label, and from I-1 to n as such here. And especially it includes instances of blight in both its early and late stage, as well as images of healthy leaves. The aim was to create a data set that mirrors the real world variability present in potato crops. Pre-process X represent the pre-processing function applied to image X, including resizing image to a standardized format, normalization to mitigate potential biases, and augmentation techniques to diversify the training samples. So augmented process can be expressed in this term. Next one is convolutional neural network architecture as on behalf of the predictive label. So we have defined the function CNN function in terms of the X, and this architecture represented in the form of the predictive label Y. Yeah.
Okay, Mr. Tyagi, can you quickly conclude now? I think you're almost
Okay.
short of time now.
So
Can you
training and
quickly?
validations, evaluation matrices on behalf of the included accuracy, precision, and recall under the proposed methodology graph as such here. So there are the different images here. Reprocessing in terms of the normalization, that we apply the clay, binary files, conversion into resize image, classifications as well as the feature extraction, means that is the training phase. Now testing phase is a dense net model and multi-class predictions here. And experimental assessment, we have taken the data from the plant village dataset. Freely available dataset Hughes and Selte was utilized for both training as well as the testing. Proposed model for the identify potato leaf disease. There are 2,152 photos in all the collections related to the illness of the potato leaves. It does, however, only provide pictures of healthy leaves and two affiliated classes, early and late blight. So there is a table as such here related to PLB. PLB means potato late blight, potato early blight, potato leaf rolls, and so on. Number of images, number of training images, as well as the number of testing images here in various 5 categories. Now, in terms of measurement, in terms of the true positive, true negative, false positives, and false negatives. So true positive as the percentage of the accurate guesses in which a picture is correctly classified as belonging to a certain class. And true negative means that is not belonging to a certain class and is in fact not part of that class. And false positive is a fraction of erroneous forecast in which a picture is categorized as negative even when it does not. And false negatives, fraction of inaccurate predictions in which a picture is categorized as not belonging to a certain class even when it does is represented by the symbol Fn. Now, as a comparative analysis, now that the assessment of the suggested deep learning model in terms of the PLB means potato late blight, potato early blight, PEB, potato leaf roll, and potato vertical wilt, as well as the potato healthy. So pH, PBW, PV, PLR, PEB, and PB. In terms of the TP, TN, FP, or FN, as I discussed earlier, accuracy percentage, precision, as well as recall, and F1 score as a harmonic mean of the both precision as well as the recall as such. That is known as the F1 score. So on behalf of the R model and the testing as well as the training here, accuracy is 97.2%. On as we have divided the potato plants into 5 categories: PLB, PEB, PLR, PVW, and PH. So as a sum up, our goal was to improve the identifications throughout the accuracy of potato disease by using a strong CNN model And with the help of the CNN complex architecture, which include transfer learning methods, many convolutional layers, was effective in identifying subtle signals that might be symptomatic of different potato illness. Our CNN demonstrated improved performance in illness classifications using a rigorous training and validation approach that included regularization, stochastic gradient descent, and back propagation techniques. So, as a summary, our model has a 97.2% accurate with these five categories: PLB, PEB, PLR, PVW, and PH. And these are the references related to the literature survey. There are 41.
Yeah,
Thank you.
Thank you
Thanks to all of you.
Yeah, thank you so much, Mr. Tyagi.
Thank you.
Interesting model again. Did you encounter any challenges in collecting or pre-processing the data related to potato diseases
Uh,
for training the deep learning model?
Challenges related to just collections. That is very much, just you can say, difficult if you are just taking the secondary data. So, how much that will be, just you can say, accurate, or how much predictions will be get the accuracy. That is too difficult in case of the secondary data. If we are collecting the primary data with the help of our, just you can say, cameras, etc. So that image enhancement is required in that case, so that we can find the accuracy. So these are the
Yeah.
challenges.
Right. Because I think that will be needed since we have that app also in which we just show it to the camera and they can tell us the disease that a plant is suffering from, but it never seems to work whenever we try to use it, right? So I think a better resolution pictures, or probably a primary data would have been better. And one more thing I want to ask you is that the developed model transferable to other regions or countries that probably have different soil conditions or potato varieties? So are there any considerations for model adaptation in such scenarios?
Yeah, definitely. Or that will also depends on the different categories, or you can say disease here. There are so many types of the disease. There may be the solanous diseases as well. There are the multiple disease at that moment here. So definitely that can be transferable, or that can be applied for this.
Okay. Thank you so much. That's it from me, Yashika. I think I'm done.
Oh, okay. Thank you.
Okay. Thank you so much. Thank you so much.
So,
is there any other author in the group? You can come forward on your own if you are there. Any author, any presenter.
So next we have paper ID 23, current harmonic reduction based on fractional order filter for a grid connected PV system. Do we have anyone to present this paper? I repeat, paper ID 28. So moving on, paper ID 58. Artificial neural network based risk management analysis of modern commercial banks using behavioral finance theory. The author is William V. Do we have anyone to present this paper? Anyone who is willing to present the paper can come up, please. Do we have anyone who is ready to present the paper?
If we don't have any other presenter, then Dr. Ranjit, I think we should not wait more.
I know. I can see a few people who've not presented so far, and there are new names, but I'm not sure why are they not speaking up. But never mind. I think let's not wait. And
because mail was already shared with all the presenters and authors that presentation is must for their publication. If they are not presenting, the publication may not may or may not happen.
yeah, fair point. Fair point. Right. So let's. Okay. Yeah, I think someone is.
Ma'am, I'm actually in a track number 5. My time is 4:15 p.m. So can I present now, or I will be there?
I think you should, if you don't have any problem, Mr. Sandeep, you should present in your own track. Otherwise,
Yeah, okay.
it may things.
No problem, ma'am. Sorry.
Okay. Yeah, if you have no problem, you should use your own track ID.
Okay, ma'am. No problem. Because track 1 and track 5 ID are given in the same. So I joined the meeting in the morning only. So that's why I'm just asking. No problem.
Okay.
I will share in my track only at the given time. Thank you.
Dr. Rajneesh, will Dr. Danish be
Yes,
there?
Ma'am, I don't think so. Dr. Danish is going to be here. I'm so sorry for that. I mean, the two papers you wanted to present, but examination duty. In fact, one of us had to be here, one of us had to be in the duty because we have very less faculty here and examinations are going on.
Okay, fine. So you can present in another track post lunch.
Maybe post lunch, ma'am. Yes.
Okay, ma'am. Then Dr. Ranjit, thank you so much. Now, with your permission, I think we should call off this session.
Right. Thank you so much for having me. It was a great experience. Very interesting papers. And I think I would like to discuss some of these topics later also with some of the authors. Very interesting papers. Thank you so much, Vanita, ma'am, for having me.
It will be an honor if we can have some future research collaborations. So I'm writing my mail ID in the chat box. So anybody who wants to collaborate, we can do that.
Sure. Right. Thank you so much, ma'am, for having me.
Yeah, Shivam and Vansh, we can conclude the session.
Okay, concluding the track 1 session, I would like to thank all the session chair, Dr. Ranjit Kaur ma'am, Dr. Vinita Sharma ma'am, and Dr. Asha Mathur ma'am for their wisdom and kind presence. Also, I would like to thank everyone for joining the session and patiently cooperating for being such a wonderful audience. Thank you, everyone.
Thank you so much. Thank you.
So my
Thank you
mail
so
ID
much.
chat box.
Yeah,
So
we've noted that. Thank you so much, Dr. Rajneesh. Thank you so much.
Thank you.
Yeah.
Thank you, session chairs.
Yeah.
And thank you, everybody.
Bye-bye. Right.
Thank you.
Right. Thank you so much, ma'am. Bye-bye. Have a good day.
Thank you, ma'am.
Thank you.
I would request IT to close the session. We can reopen the session again post lunch. Thank you.